Good afternoon, everyone. Hello, everyone. I'm glad to see this large turnout that we have here today for Mike Hawthorne from Princeton Hydro. Uh, the presentation you're going to see today is kind of the same one we started in the board meeting in December. We didn't get all the way through it due to the time constraints. So Mike is going to do it again. We will have questions and answers. We'll go over a little bit of the stuff that we've done this year, some of the stuff that we're looking for next year. We're going to discuss probably doing some of the floating islands, things of that nature. So again, we'll go through the presentation. Mike is very knowledgeable on lake management. You can ask him almost anything, and he probably will have the answer for you. So, Michael?
Thanks a lot, Joe. Yeah, great turnout. Good to see everyone. Thanks for coming. We're excited to be here. Um, yeah, I want to go over kind of like the lake management plan that we started to develop in 2023 and continued into 2024. Really, the premise of the lake management plan is to characterize the lake and the watershed, collect water quality data, plant data, and so forth to really understand the system that you have, to identify any potential problems, to provide recommendations to fix those problems or improve those problems, and to prioritize them. I will say, we work on a lot of lakes, and the two lakes you have here are pretty great. We're dealing with a lot of lakes right now with a lot of harmful algal blooms that are shutting down swimming beaches and all sorts of things. But took a nice tour this morning, and you have some great water bodies here. Overview of the presentation. We'll have a little bit of background information on lake ecology for folks that may not be as up to speed on it. So provide some context to the rest of the presentation. We're going to present some of the water quality info we collected last year and what we have to date this year. Discuss our watershed survey that we conducted last year with our ecologists and stormwater engineers. We're going to go over some preliminary recommendations, both in lake and in the watershed, and most importantly, get your feedback. You all know the lakes and the watersheds really well. You're out on the water a lot, so we want to have that feedback from you. So we're ensuring that the recommendations are really top notch and will work out. So any questions you have at the end, we'll go through those and answer those. The scope of work for 2023, we started the lake management plan. We reviewed some of the historical data, did water quality testing 3 times over the course of the growing season. So like May, July, September. Did aquatic plant surveys, detailed scientifically based transects at each lake, characterizing the aquatic plant communities. We did that watershed assessment to evaluate potential areas that could be improved with the stormwater, riparian buffers, erosion, things of that nature, and then integrate that into a lake and watershed management plan. And really the purpose of that plan is to kind of serve as a blueprint for how to manage the lakes. It would be a living document that will update as we gain more information and implement management measures. And the great thing about it is, that document can be used as boards change, as committees change, and just kind of be used as a guiding mechanism. In 2024, we continued our water quality testing 3 times, plant and algae control through different means, herbicides and mechanical removal. And then we're also conducting a pollutant and hydrologic modeling of the watershed. And that's basically where we're quantifying the amount of phosphorus, nitrogen, and sediment that are coming into the lakes, and also the water balance of the lake. So what's the inflow? What portion of that is stormwater runoff? What portion of that is groundwater flow? What does that look like over the year? Do we have certain months where that's heavier? Typically we do in the spring. And that relates to lake flushing and algal growth and all sorts of things. So we're looking to do that modeling this fall. So lake and watershed management, the way we approach it is that every lake is unique. every lake's going to have its own characteristics, its own potential problems, and we want to tailor management measures to those lakes. They're not isolated; they're a reflection of their watershed. So the quality of the watershed of all the land that drains into the lake has a direct impact on the water quality of the lake. So we're not looking just at the lake, just at the watershed. We're looking at both as a unit to improve those. Data collection, we're checking, quote, the health of the lake. We're monitoring during the growing season, which is typically when plant and algal issues are the worst. We're using that data to evaluate water quality and how it's different annually and seasonally. Certainly this year in this region of Pennsylvania, we had a very wet spring, followed by a somewhat dry and very hot early summer. And that's a little bit unusual pattern. So how does the water quality respond to that? And we want to basically understand the causes and the sources of what we call eutrophication. That's just a fancy word for high levels of algae and plant growth. So are there certain areas that are contributing nutrients as hotspots that we can manage to reduce that plant and algae growth? That's what we're looking to determine. All sorts of data we're collecting. We do not do the bacteria testing at the beach. That's a different company that does that. But we're testing for a lot of the nutrients in the water, different phosphorus fractions, nitrogen, solids, chlorophyll A, looking at things like dissolved oxygen, temperature, pH, and evaluating kind of the base of the food web. So we're sampling for the phytoplankton, which are the microscopic algae in the water. And we're looking to see what types do you have. Are they things like folks may know of diatoms, really pretty silicate-based algae. They provide a brownish coloration to the water, and they're good algae. You typically don't find those in high densities in impaired lakes. Things like the cyanobacteria or blue-green algae are typically indicators of impairment. They thrive in very warm water, very high phosphorus concentrations, and stagnant water. So it's important to characterize that base of the food web, and that's a big part of what we do. We also look at the zooplankton, which are the little critters that feed on the algae and subsequently serve as food for fish. This is an ongoing process, so we haven't done any fishery surveys, but we have seen some of the creel data that has been provided by the anglers. This management, we do it in a data-driven manner. We want to use that information to identify the problems and to really objectively understand if our management is making a measurable improvement. We want to make the most efficient decisions for the lake, and that data helps us do that. Again, as we discussed, that plan is going to be adaptive as conditions change, and most importantly, it's going to include your input, which is really valuable. There's also kind of information within this plan of how to do these things, like where could we have technical or financial assistance. We talked to Joe a lot about what potential grants we might be able to look for to help implement some of these projects. There's also a big educational component, right? So talks like this, kind of updating the community on what we're doing, getting your feedback, answering your questions is really important. So there's kind of like a few sections here. We're going to go through the water quality, then the plant data from last year, and then the watershed. And within each of those three sections, at the end, we'll provide some preliminary recommendations germane to those sections. So we're conducting 3 events, typically May, July, and either August or September, depending on how the season is going. Again, a lot of the parameters that we discussed before are listed there. That's Katie Walston, one of our ecologists collecting transparency data. Spatially, we're covering a good number of stations, especially in Arrowhead Lake, where you have a lot of these coves where you might see stagnant conditions or high levels of plant growth or sediment buildup and things like that. So, we have a number of stations to Arrowhead Lake. We do sample each of the beaches as well, especially for the algae. We want to see, do you have cyanobacteria at the beaches that could potentially have adverse impacts on swimming, or things like pets going in the water and so forth. So we pay close attention to that. Also, the streams that come into the lakes and the outlets. So we have a pretty good overview of spatially of the water quality of the system. So we're going to kind of look at 3 of those parameters today, and they're all interrelated in lakes. So phosphorus is typically the limiting nutrient, meaning small increases in phosphorus can result in big increases in algae and plant growth. General rule of thumb is 1 pound of phosphorus can produce 500 to 1,000 pounds of wet algae. So when we talk about phosphorus, you might say those are really small numbers, but they can translate to really high levels of algae growth. So we do want to understand what those levels are and how to keep them in an optimal range. So we provide kind of 2 thresholds here. The lower one is the yellow bar, and the upper one, 0.05 in the red line. That's typically what we're going to use for your 2 lakes. They're not natural lakes. They're basically dammed wetlands. So they're naturally going to be a little more productive than, say, a deep glacial lake that has like rocky bottom and so forth. So we look at 0.05 as the threshold. And you'll see last May of last year, we did have an exceedance, a little bit of a bump up also in last August as well. But for the most part, you have moderate phosphorus levels. So, anywhere from 0.02 to 0.05 generally. So you're either at or below that threshold, which is good. Chlorophyll A is the pigment in algae. So the more phosphorus you have, the more algae you have, and the higher your chlorophyll A is. We have a threshold of 20 here. We're typically, well below that in the open water stations. We did have some exceedances at the beach periodically and temporarily, but in terms of the open water, we're all well below that threshold. And the more algae you have, the lower clarity you have in the lake. So we also measure Secchi transparency. It's just simply how clear is the water. We'd like it to have a threshold of 1 meter, which is 3.3 feet. Typically, when your transparency gets below that, lake users will say it looks kind of scummy. We don't want to swim in it. We think we have a problem. So we use that as a general threshold. Now your lake's interesting because it's also very tannic. So you notice that brown coloration. It's due to a lot of tannins and so forth in the lake. So your transparency is also naturally going to be a little bit lower because of that natural shading. But overall, you're typically near or a little bit above or below that threshold. We had a dip in August of last year in 2 of the stations, but 3 out of the 4 are pretty good. Kind of point out some of the potential issues we're looking for when we're doing our testing. Like last year at the beach 1 at Arrowhead Lake, we had an early season accumulation of that cyanobacteria. We're determining what the genus is, and we're enumerating it in cells per milliliter. And we can compare that information to standards in Pennsylvania, and also adjacent states have them as well for cyanobacteria cell density. These are the type of algae that can form what's called harmful algal blooms. They have the potential to form toxins. They don't always form them. And sometimes when they form them, it's in very low levels. We do test for that as well. But that's kind of some of the stuff we're looking for. This bloom was kind of temporary. It dissipated relatively quickly, so it didn't really manifest into any longer term issues. And so far this year, let's see. I'm sorry. So this is also last year. These bars just show the composition of the different types. You'll see in May, that big blue bar, those are cyanobacteria. And talking about the nutrient inputs and how it relates to that, you see your total phosphorus is much higher than the 0.05 we were looking for. It was 0.13. Chlorophyll was higher than that 20. It was 66. So we do have very limited instances of these beaches that may have, um, some blooms. So we're always keeping an eye out for that, trying to understand what's causing them and how we can remediate that. So far this year, we did not see any high levels of growth in May. We did just conduct a June or a July event on Tuesday of this week, and we got some of the plankton data analyzed. We do have some kind of moderate levels of cyanobacteria at the North Lake Beach. I was just up there this morning. The water looked great. So this is nothing that we're concerned about, but kind of like the type of data we collect to keep our eye on. And so when we get information like this, we'll talk to Joe and say, hey, we have a little bit of cyanobacteria here. Keep an eye on it. They know what to look for. We've worked with him for a long time. And we can use that information to let residents know if we do detect any issues. Another thing we look at is the dissolved oxygen of the lake. The DO levels are important for a few things. Number one, all the aquatic organisms, the fish, the insects, and so forth, require oxygen, and they typically like to have it above a level of 4 milligrams per liter. Below that, the fish can get unduly stressed out. So we measure that throughout the water column from top to bottom. And you'll see in some of the lakes, like North Lake, but this also happens in Arrowhead Lake, just kind of towards the bottom there, you get a little bit of a rapid drop off in DO, where it's not only below that threshold of 4, it also can become what's called anoxic, which means 0 oxygen. And that's below the level of 1. And the impact of that in lakes is there's phosphorus not only coming in from the watershed and so forth, but there's also phosphorus in the sediments on the bottom of the lake. And it can be complex to a number of different metals and so forth, one of which is iron. And when phosphorus and iron are attached in oxygenated conditions, that phosphorus remains bound up to iron, not really available for algal growth. When we have that dissolved oxygen drop out, that bond can break. And then you can get some leaching of phosphorus from the bottom. So you can not only have stuff coming in from the watershed, you can have stuff kind of coming up from the sediments during the period where algal and plant growth are the highest, say in July and August. So we measure that, we look for that, and there's ways to remediate that as well. Some initial recommendations, things like aeration could be implemented where we're seeing anoxia. We did collect data last year and we're collecting data this year. We want to make sure before we move forward with any type of management recommendation, we have enough preliminary data to say this is definitely where you have the issue, this will work. So this type of system, it's simple. There's a compressor that sits on the shoreline. It's connected to these diffusers, these purple circles, via like weighted airline tubing. And it simply pumps air bubbles up. And the point is not to introduce oxygen via those air bubbles, it's just to keep the lake vertically mixed. So the bottom waters can come up to the surface and oxygen can be replenished by the atmosphere. So that's one way to help have those water column get oxygen in it. This is kind of what it looks like in action. Those are a diffuser array on the left. And what you would see if that were in your lake is just kind of like a gentle bubbling on the surface. And those would be placed kind of strategically throughout to keep that water column mixed. They can also be utilized kind of in a curtain fashion. So putting those diffusers in a line where you have kind of a bubble wall. And those can be really effective if you have a beach that's getting a lot of windblown algae and detritus and things like that. It's just a way to help kind of repel that a little bit and keep those beach areas clean. We've had a lot of good success with that. In this neck of the woods, we've done them at Big Bass Lake Community, and that's worked out really well for their main beach. There's different ways to control phosphorus. Again, like your levels are not screaming high. They're typically, they're moderate with a few exceedances, but there's a number of ways to kind of capture and remove phosphorus from the lake. One of which is something called biochar. It's basically pyrolyzed wood, superheated wood, similar to charcoal. It's inexpensive. You can put it in these mesh bags, and it can attach, phosphorus and nitrogen and so forth can attach to that material. And we typically would deploy that for, say, from April through September, pull it out at the end of the year, and then put fresh material in, the following year. This can be done in lake. We often use it, like say you have a stream coming in or a stormwater gully. You can install it kind of in the lake where that water comes in. It can help polish and remove some of those nutrients flowing into the lake. Another way is through products you can purchase, both kind of brand name and things that are utilized by waste water treatment purveyors. So there's lanthanum/clay based products such as Eutrosorb Phoslock that are applied in a slurry, and the graphic up top basically shows what occurs. That phosphorus that's free in the water attaches to this clay and lanthanum, sinks to the bottom, and it's inactivated. There's other chemicals that do something similar, like aluminum sulfate is used very frequently in water treatment as a clarifier. That aluminum also can bind to phosphorus, and that bond doesn't break when oxygen drops out. So it's a strong bond. That's another product that's often used in lake management to either strip the water column of phosphorus or to seal those sediments, so there's not phosphorus leaching up. We haven't detected levels in your lake and resultant algal blooms. I would say that this is needed at this point, but it's something we keep in our back pocket should we need it. Another natural way to kind of suck up phosphorus and other nutrients are floating wetland islands. Just a recycled plastic matrix that's buoyant, has holes in it where you plant wetland or water-loving plants. And you can deploy those in the lake, either anchor them or moor them to the shoreline. And basically, the plant roots, and most importantly, like the microbial community and the biofilms in that high surface area of plastic matrix, are pulling nutrients from the water column that otherwise would be assimilated by algae. So you're basically looking to compete with the algae with these natural systems. And here's kind of a schematic that one of our ecologists, Ivy Babson, drew on the function of the islands. You'll see, especially the roots that dangle down into the lake, they'll sequester nutrients for plant growth. And they also provide kind of like habitat for zooplankton and small fish. So, oftentimes when we have lakes with these, fishermen love them because, they'll be able to kind of target that. And, maybe there's a largemouth bass hanging out there waiting to ambush some of those smaller fish. One thing that was, we received a lot of great questions and comments when we issued the draft plan the previous winter. One of which was like on the sediment accumulation and the sediment quality and so forth. So one way to determine where you have sediment and how much sediment you have is a bathymetric assessment or a bathymetric survey. The community did have one in 2020, I believe. But if there's ever concern about sediment accumulation, this is one way to determine where it is and how much volume you have. And it's kind of the first step in evaluating, do we need to do spot dredging? And if so, where? And this is done by running a boat with a dual frequency fathometer. It basically bounces a sound wave off the top of the sediment. That gives you water depth. And then another sound wave goes through the unaccumulated sediment to the original lake bottom, bounces back, and that will give you your sediment profile. And then you can map contours after you do some 3D modeling that basically show where that sediment is and how much. So that might be something, down the line, the community would consider. There's also can be sediment testing done to see if there's any contaminants or anything like that. I think the setting of your lake being in a natural area, you don't have a brake pad plant in your watershed, things like that. So more than likely your sediment's, clean compared to disposal criteria that the state would have. So that's the water quality data, some of the in-lake management measurements that might be helpful. Moving forward, we did that plant survey last year, and we always make observations and management this year as well. So we'll go through some of that info. Again, we did this line intercept plant survey of both lakes. We want to document what species are there, their distribution throughout the lake, and their biomass, or what's the weight of them in the water column. We want to look for native plants, which are ones that are great for the ecosystem that we want to keep in the lake, and we want to foster their growth. And then we're looking for things like invasive plants, which we should target for management and removal. Did 12 transects in Arrowhead Lake, 6 in North, and that survey was conducted in August of last year. And we've received a lot of great comments following this with some additional species to add. But we identified in North Lake, 4 submerged plant species. They were all native and beneficial. 2 are of what are called emergent plants, so plants that grow kind of with their feet wet, but the bulk of the plant growth is above the water. Things like cattail or Phragmites. Phragmites is a non-native invasive and one that we would target for removal. But overall, during the survey last year in North Lake, we had low densities of aquatic plants. Arrowhead Lake, we had more species identified, 11 submerged, 2 floating, things like spatterdock or water lily, 2 emergent, and 1 macroalgae, which is it looks like a plant, but it's actually an algae. The only invasive submerged plant we identified was curly-leaf pondweed, one that typically grows early in the season, oftentimes dies back by Independence Day. But that would be one that we want to target for management. And then also there's been previous work done on the yellow iris, some volunteer efforts to remove that and some study. So we were informed that that is throughout the shoreline. That wasn't managed this year because it's already gone to seed, but will be addressed next year. So some kind of like plant management measures we've discussed and are part of the scope of work for this year is either herbicide application for plant removal. That can either be contact herbicides, which are applied and kind of burn the plant tissue, or things like systemic herbicides that the plant slowly takes up in low doses and can kind of selectively target some of those invasives, like curly-leaf pondweed. So those are the 2 herbicide types. But also what we're excited to start here is some mechanical removal. It's a non-chemical means where you're basically, you can either cut the submerged vegetation and remove it. There's some like a clamshell dredge and so forth where we could pick up and remove cattails and remove the rhizomes with those and so forth. So we're hoping to do some pilot work with that trucks or machine a little later this summer. This goes over some of the management types for those specific invasives. Curly leaf pondweed, really any plant can spread via fragmentation, but this is one that is pretty adept at doing so. So either a low dose of a systemic herbicide like a fluoridone or a contact herbicide would work. We would say probably use the herbicides over harvesting for that plant specifically. Phragmites and iris, you can do foliar treatments in autumn or September. or you can remove it mechanically with something like the trucks, or you can pull it up with the roots. And moving to like the final portion of the lake and watershed management plan, we also did a watershed survey where we just did a on the ground tour. We looked at the stormwater infrastructure, the streams, and things of that nature to identify kind of like acute areas of erosion or impaired riparian buffers that could be improved. And really the point of this is to just clean the water that's coming into the water bodies. A lot of that stormwater runoff is called non-point source pollution. It's not necessarily like a discrete input from a factory pipe. It's ubiquitous throughout the property. It's diffuse in a general sense, and it's something to manage. So non-point source pollution broadly covers things like stormwater, wastewater treatment. A portion of the community is still on septic, so something like that we would focus on. Stream bank erosion and impaired buffers. Also things like lakeshore erosion, where we may have the lakeshore unvegetated, it might be eroding, receding, and those sediments and nutrients are going directly into the lake. So stuff like that we're looking for. And a lot of this is exacerbated by kind of like the alteration of the hydrologic cycle. Basically, there's kind of two things we look at for that. One of which is our rainfall patterns are changing. We're getting heavier rainstorms more frequently. So we're getting a lot of these big deluges that are flushing a lot of sediments and nutrients in the lakes. And that can be exacerbated by just building the watershed. So the more roads and roofs and impervious areas you have, the higher your non-point source pollution will be, because that water is not going to hit the ground and slowly infiltrate. It'll hit the roof, run off quickly, run into some dirt, and then go into the lake. So we talked about this, we did the survey, took photos, GPS points, measurements, and then took that information back to the office and looked through some what are called collectively best management practices. So stormwater measures to improve those areas. And we're really focusing a lot on green infrastructure, basically utilizing mechanisms that are already present in nature to intercept and treat the stormwater. Relatively simple conceptually, things like rain gardens. You take the stormwater source, direct it to a vegetated depression, and you have a few different things going on. You'll have the ability for some of that water to infiltrate slowly in that basin. Also, the plants will be taking up that water and transpiring it to the atmosphere. So you're dealing with some of the stormwater volume that way. And those plants and microbes and so forth are also pulling up the nutrients from that stormwater, keeping that in the plant biomass so it's not going into the lake. So they're great for stormwater treatment, relatively easy to implement. Grant funders and so forth love to provide funds for these types of projects. And they also have a great habitat benefit. I mean, planting these with native wildflowers and so forth are, a big help to our pollinators. So we certainly look to implement this type of BMP wherever we can. And some of the things we saw this morning and during the survey is, there's a lot of areas where you may have parking lots and you have gullies and so forth where the runoff is collected and then it goes through a conduit to a stream directly to the lake. Well, what if we kind of, regraded those a little bit, improved the substrate and added some native plants? Well, we'll get a lot of those stormwater benefits that we're looking to achieve. This is one example of a place where we could consider that. You'll see kind of have some hardtop there, some gravel, but we do have this stormwater gully that we could go in and kind of regrade a little bit and make it better with some bioretention features. And this is just kind of like an excerpt of the numerous sites we checked. things like bioretention swales again in the parking lot. You'll see on the right side, just kind of a little bit of erosional depression where water seems to be going. We could vegetate areas like that just to slow that water down and to improve it. And these rain gardens, they can be implemented not only like kind of on the community land, the parking lots, the clubhouse, things like that, but you as homeowners can also utilize them in a small scale. Bottom right is a rain garden that was installed by a homeowner. He directs his downspout there because he had some recurring flooding issues, and that has solved those issues. A little bit of a larger sense that upper rain garden is one we designed and installed at the Harveys Lake Municipal Building in Luzerne County to address some flooding issues they had there. Some more examples of these gullies, and these are features that are common in most of the lake communities in the Poconos where there's not concrete stormwater infrastructure. You have these gullies that were dug. Lots of times they're undersized for the amount of rain we're getting now, so you could have some overtopping. A lot of the problems we'll see is twofold. You might have areas where the water is flowing through really quickly and scouring the gully itself, so that can serve as a source of pollution. And then you have other areas where that water slows down, the material accumulates, and we really want to identify those areas and make sure they're being targeted for maintenance. So removal of that leaf litter, gravel, grit, nutrients, all that stuff. Remove it from the stormwater system before it goes into the lake. So any of these BMPs, really the key to their functioning is the operation and maintenance, not installing them and forgetting about them. This is kind of like an example of one way to maybe tweak those stormwater gullies a little bit, look to nature for some ideas. Step pool conveyance system, basically to try to mimic some functions of a stream where you may have the water going in, go into a pool that slows it down a little bit, a rock pool, lets the sediment and nutrients drop out, and then continue on. So you're just slowing that velocity down a little bit, letting that stuff settle out where it can be removed at a later point or assimilated by plant growth. Also things like shoreline restoration. I haven't seen any areas in your community that are this bad as the one on the left. But this is actually a retirement community we worked at where they had some severe stormwater erosion, and that was planted with a nice mixture of Monarda, Black-eyed Susan, all sorts of natives. It has a really different, has a color palette that kind of changes throughout the season, so there's always something fresh to look at, and it arrested that erosional source there. So we look at stuff like that for your community as well. Canada geese management, they're like little cows with wings. So, they're eating a lot of the grass, a lot of the turf grass, processing that quickly. A goose can produce 0.13 pounds of phosphorus daily. There's actually some poor graduate student wanted to do that as a project and had to collect all that information. And that may sound small, but remember, a pound can produce 5 to 1,000 pounds of algae. So if you have a resident population of, say, 40 Canada geese that aren't migrating back north when they typically should we manage that to help reduce that source of nutrients, reduce that eyesore, and reduce that source of bacteria loading, from their droppings? It's like the culmination of the watershed portion. So next steps, what we're doing this year and what we're looking to do in the future, pending your feedback. At some point, we'd like to evaluate the fisheries in a greater sense with a fisheries survey in a few years from now. Continue the water quality monitoring. We do think the floating wetland islands and biochar would be a good natural means to help suck up some of the phosphorus in the lakes. We'll collect more data this year and evaluate that aeration technique and see if it's definitely needed, and if so, where. We'd like to do some pilot projects with the trucks or harvesting some of those nuisance plants to reduce our reliance on pesticides. And then we're always keeping our eye out for potential grants for the community for stormwater projects. One of the challenges is a lot of the grants are for publicly accessible locations. But we still keep our eye on those in case we could find a sponsor that would make your community eligible. That's through the state, through things like DCNR, PADP, and other avenues. And with that, I would love to answer any questions you may have about the presentation or any of your other concerns. Thank you.
Thank you, Mike.
Hi, I just wanted to ask you about the floating wetlands island.
Yes.
What happens to them in the winter? Do we have to remove them? Because our lake freezes and then start from fresh next season.
They could actually, you can leave them in through winter and the plants will spring back the next year. Actually, a lot of the company where we get them from is in Montana. They do a lot of their testing there. You just leave them in and they'll spring back up. Really, the only maintenance you need to do is the first year we would put fencing up so geese and mallards won't eat the fresh plugs. But once those plants are established, typically a year, you can take that fencing down and really, that's all you have to do. We get a lifespan of about 15 years out of them. After a while, the UV light just breaks that material down. But the manufacturer has improved that UV resistance. So we get a fair amount of time out of each island. 15 plus years, I would say, yeah.
I'm over here. Comment and an observation on your presentation with regards to Beach 1. You noticed the May data that you saw an uptick in potential toxins and other issues that may affect the water quality there. I don't know how much investigation you did as to some events, but I can tell you on Beach 1, we had an unfortunate event where a deer walked across the lake during ice and fell through and actually decomposed right in front of Beach 1. So that potentially could have played into some of those results. Just to, there's the kind of things I think when we see an uptick, then we should look at other environmental impacts that could have caused that as well. With regards to observation, I'm on the North Lake and have been there 7 years. And I can tell you, this is probably the first year that we've seen significant growth in weeds and in a spreading manner than any year prior. And, would really like to see this action plan go in place to reduce that, just because we have a lot of people in that lake in particular.
Yeah, and if you see those conditions, if you're able to snap a photo, and share that, we can and send it to the office. That info will make its way to us, and we can take a look at it. A lot of times when our applicators are evaluating the lakes for treatment, plants overall, they're good. I mean, you want plants. If you don't have plants, you're going to have algae. And they're really good for the fishery and so forth. But we do want to manage them that you're not getting your oars stuck. They're not a visual nuisance in front of your house and things like that. So we want to be pragmatic in how we do it, but it sounds like, maybe you have some issues. So send those along and we'll take a look. Yeah.
I have a question on aeration. Now you have these pods that generate oxygen, right? I'm not sure exactly. Say again?
They push, it's just air.
Air, exactly. Yeah. Okay. How many of those would you need in our lakes here to be effective?
That's something we would have to size out. We didn't size out the system, but we would look at the volume of water, the acreage, and also the temperature profile, and then from that determine the number of diffusers that would be needed. But I don't know that right now.
Regardless of the depth and the water temperature, obviously that's crucial to the decision. But can you just give us a ballpark figure, the area that with ideal conditions and temperatures it could handle?
So, over here.
It's tough to say. I would have to sit down and do the math to give you like even a somewhat accurate answer.
So
Dave.
on the sample plan, it looks like the North Lake stream coming in isn't a point. Just seems like that would be a key data to collect what's coming into the North Lake.
I'm just pulling up the sampling map again. Yeah, that is one area we could add a station. You know, we have the outlet of north, but we don't have that inlet stream, you know, so we have some of the others. That would be something we can consider adding for next year. Yes, sir.
Back in December, you made an offer to answer questions that were submitted. In February and March of this year, several of us put together some well thought out questions, and I believe you received them. When will we get answers to those questions?
I thought I provided those. If they didn't make their way to you, I can send those to you this evening.
What did you say?
He said he'll send them to him.
But if you had any specific ones from that list that you'd like to ask now, I'd be happy to answer them.
You brought up the question of silt. Back in October, I had nothing else to do, so I went around and did a silt survey of my own. I found locations not too far from here where the silt is 2.5 feet deep. Doing some other research, I saw a connection between silt and E. coli, where E. coli can reside in silt,
It can.
survive a winter, and come back again. So the elephant in the room for a lot of people here is E. coli. You say you don't address it, but let's talk about it from a system standpoint. Some of the silt in this lake is light soil components, and some of it is degrading foliage. I don't believe this has been addressed. Silt in other areas of the lake is close to zero. Some of it may be due to wind direction. Some of it may be due to locations we've identified where perhaps 30 tons of silt has been introduced to the lake from one stream location. That's not too far from here either. My concern is that back in 2017, there was a plan put out to reclaim the lake, but the plan was never fulfilled. Parts were done here, parts were done there. Many of the efforts to reclaim the lake were abandoned. And I think we've got a silt question here that has E. coli issues. It has water pH issues. There are areas where you can drag a light weight through the silt and have an effervescence of the water. It's either releasing carbon dioxide from carbonic acid formation or it's methane. I'm not sure which it is. But I don't want to, in your plan, see an overlooking of the silt question. It's significant.
Yeah, the question about silt, I mean, I don't have the information of the dredging plan that was done in 2017. But, you know, if you want to have kind of like an updated mapping of the silt, where the densities would be, you could do that bathymetric assessment.
It's not a question of finding it. It's a question of getting rid of it.
That you need to dredge it out.
Yeah. Which was the plan in 2017. But it never happened.
Okay. Yes.
Hi. My question is slightly different. I wanted to know about the biochar bags. If that's something that we wanted to implement on an individual household basis, if we're on the lakefront, is that something that we could just make or buy on the internet? Or is that something that would have to be done community-wide?
Yeah, it's lots of times how we approach it, and you can approach it a number of ways. Sometimes we'll kind of train folks just, on where to get it, how to tie it up, when to dispose of it and stuff like that. And then let people do it, like tie it off to their docks and so forth. Some folks feel comfortable just doing it on their own, without training. It's pretty straightforward. I mean, it's just putting the material in the bag, tying it off, and then, replacing it after 6 months. So, yes, sir. Don't dispose of them in the trash.
No.
Yes, ma'am.
I'm sure you probably know this, everybody does. There's a new dam being planned for the North Lake. Now, what effect will that have on the water there and the water in that dam enters into?
I know there's a new spillway being planned for the North Lake. I'm not exactly sure the construction sequencing of that, like if they're going to lower the whole thing or how that's going to be done.
So with that, Mike, they'll put a coffer dam in around the current spillway, drain that down and work just in the spillway area within the coffer dam. We will probably lower the lake a little bit to relieve some of the pressure on the coffer dam, especially if we know we have a storm coming in. We'll take some of the water down and let it the storm water run into it so that we don't lose the coffer dam.
Yeah, typically that work's done, in the colder months. So they would provide enough refugia in that water pool with the coffer dam for any of the fish and so forth. And then typically the work's done in the colder months to minimize, DO depressions in the water, smells and things of that nature. So typically, there's not any acute issues on the lake itself when that's done. There's timing restrictions for things like bald eagles and so forth, but that's a common method to do it, Joe. Yeah.
Yeah, all that whole plan will be done with again at Fleming and.
I guess it depends what happens to the Migratory Bird Treaty Act. But,
So I can chime in on this one. We have had the USDA aphid division, which is the wildlife division out of the USDA. They have come in and they have done a roundup this year.
Excuse me, you use pesticides and herbiciding, or this last June, did you use those?
there was an herbicide applied last week.
I'm saying, while you herbicide, you use pesticides or no? Just.
Yeah, an herbicide, pesticide, the terms used interchangeably, but yeah, an herbicide.
I'm sure everybody has a question. How does it affect our wells, fish, drinking water? It's pesticides. It's not even E. coli that get filtered with sand.
I mean, there shouldn't be any impact to the wells. They're,
What effect would that have on us?
in what sense?
Herbicide. I mean, my
I-
hair
there's-
problem, cancer, all those goody little things that come along with that.
I mean, there's typical, I don't think it's going to have any transport to the well. Like if you have a deep well and this is just like a surface water application, it's typically, taken up by the plant, it's specific to the plant physiology. So the impact to like vertebrates is, in the dosages applied, the impacts to the vertebrates are not significant. It breaks down. I mean, it depends on which herbicide you have, but it degrades. Not in the concentrations that are being applied. I mean, everything's concentration dependent. So as part of the approval process for it with the EPA, it goes through that testing. And then there's a label for each pesticide that says if there's any potential impacts to vertebrates, groundwater, swimming, things like that. So the contact herbicides degrade relatively quickly, like within a week. The systemic herbicides might take, upwards of 30 days to have a non-detectable concentration. It depends on which one. The contact herbicides, like typically like a week. Things like Florida. Yes. Yes.
Are they available?
Yep.
My question is more to my house has a gully in between my house and my neighbors. The leaves just pile in there. For 23 years, we've been cleaning them out. But as we're getting older, it's getting a lot harder to clean from the road all the way to the lake. That gully, is there something that could be put on top of it so the leaves don't go in it? Is there something that could be done? Can the leaves, I just heard you on here, you say that the leaves shouldn't go into the lake. So if we're not cleaning them out, they're gonna go into the lake, or the water's just gonna.
Yeah, right. I mean, it's a maintenance thing. It's removing them from the gully, as opposed to trying to cover it up or cut trees down. And you have probably miles of gullies in the community, so I'm sure they're trying to prioritize and remove where the most severe issues are. But yeah, they can be scooped out. I don't know who's responsible for that in your community.
Generally, the soils are maintained by the homeowners, especially in this instance between the houses, it would be by the homeowners. That would be, we'd have to look at the storm system on that one. That would be a completely different process than with this. So I'll get with you and get your street number and we can look at that.
Yeah, I mean, really the answer is to remove it manually, I would say, over trying to cover it up and stuff like that. It's one of those maintenance issues, and if folks aren't able to do it, if it's their responsibility, ask a neighbor to help, hire someone, but it should be. Okay.
Excuse me, cycling back to the silt problem we have in the lake. We're over on we're on the big lake over by Beach 2. When we moved here close to 30 years ago, the depth of the lake was over our head in a lot of areas. Now you could basically walk across the 3/4 of the lake. It's now up to our knees, if not even less. There's been a really bad accumulation of it. We keep hearing that the lake is our greatest asset. How are we addressing this situation? It's getting shallower in so many areas.
One of the things we can do, and Mike had mentioned it, was we can get the bathymetric silt study and get some data points to start with, and then we could apply for some dredging and do it that way. But the big thing Mike did say is we have to get the study and get an idea of where and what the issues are within the lake.
Yeah, you would want to map it out, see where those worst areas of sediment are. So you might have some areas of the lake that have 5 feet of sediment and some that have 2. Map those out, see where the hot spots are, the worst areas, and then prioritize those for removal. It's a process, so you have to understand where you want to do your work, and then there's permitting involved, there's different types of removal, dewatering, storage. So it's a process, but it can be removed.
Can I ask a follow-up to that? I'm fairly new to the lake. We bought about 2.5 years ago. So if the study was done back in 2020, was there any action taken based on the bathymetric study that was done then? Or 2017, whatever year it was?
17, I know they did do some dredging. They ran into some issues over in the Lewis Creek area of the lake. That was more of a spoils area when they were building the community. So there's a fair amount of stumps and rocks and pretty big areas over there. As far as the other basement, the other study that was done, there was nothing ever done from that I could ever see.
Would that theoretically, like if the silt is sitting, would that be a place to start with? If there were certain areas that already had a significant amount of sediment built up, would those be places that we could potentially begin to dredge if they've already demonstrated accumulation over a significant amount of time?
I think I would have another study done just to make sure I have the right hot spots before you jump into dredging. Mike, I know Mike and I have done some dredging at other facilities. You want to make sure you're going to spend this money wisely and go in and get the right areas and put out a very good plan. But even from 2020 to now, I'm sure you've had more silt to have gone into the lake. And Mike and I are trying to work on some stuff with stormwater to alleviate some of those areas as well. But again, you want the study, and then you would pick your hot spots, and then priority. Let's say you got 5 feet in one area and you said 2 in another. We're going to take the 5 foot first, and then keep working our way through to get to the lower levels.
Okay, my next question. Sorry, I'm asking a lot of questions. I'm just trying to learn.
And I agree with you. I mean, it's at least 5 years old. I would update it. Yeah.
So then the question would be, is there any reason not to dredge? Like if there was one study already done and it demonstrated buildup, and is there any aversion, risk, or detrimental effects to dredging that would cause us to not want to do that?
No, I mean, typically the things that stop people from dredging are the cost, and if there's severe pollution. I don't think you would have polluted sediments here. So it's mainly a cost-driven issue or logistics, depending on where the accumulation is. That's typically, there's temporary suspensions of sediment when you do the operation. Again, it's typically done in the winter. There's normally a sediment curtain to localize that suspension. Any impacts to the lake are typically minor and temporary.
When they did, Rich and Rodney, I know you guys were, I know Rodney was on the board, I think, at the time. When did you guys dredge? Yeah. Rich, grab the mic. Mike, grab the mic.
It was a while ago. It might have been earlier than 2017.
Okay.
But what they did do is they didn't dredge the whole lake. They dredged channels around, especially around in the Eastern Cove, so that boats could get through, but the whole lake was not. And they ran into problems they hit bedrock pretty quick. And like you said, stumps. But that was a while ago.
Okay.
And that's a common problem. I mean, a lot of these old flooded wetlands is stumps and boulders and stuff getting in the way.
Pardon?
I was just saying that's a common problem with the stumps and boulders, especially if you're dredging hydraulically in the wet. It can be a big impact. Yeah.
Actually, I'm not sure. Didn't we have to change contractors? Or,
Yes, you did.
because they're the first contractor quit on us, because of the problems. But if I can continue, that's something you're saying about when they start that North Lake spillway
Yes.
and they're liable to drain the lake somewhat, a lot.
No. Rich, what they'll do is, we'll use a gate valve we'll get a level that we're going to maintain so that we're not going to put a lot of pressure on that, coffer dam. And again, when they're doing that, we got to put the coffer dam in, and we're not going to drain the lake. That's why we're doing the coffer dam. So you got to try to put that in there so you don't have a lot of pressure on it. So in case you have a heavy storm, we don't want to lose it, especially if the spillway is not in there. It would be like a bathtub pulling the plug on the bathtub, and we don't want to do that. So,
Well, this is just like a forewarning for your company, Mike. The last time they drained that lake, which they drained it all the way down, when it finally filled up, and it took a year or so, the weed problem was terrible, and they had to get one of those weed eating machines in. Just a heads up.
yeah, we won't go that far, Rich. We're again, the coffer dam will be the only place that will be well, it won't be 100% dry, but it'll be, the work will be in the coffer dam. And if they bring it down, Rich, I'm guessing we're talking maybe 6-8 inches. They'll bring it down. We're not talking a lot.
Yeah, so that, I mean, if that's the case, you shouldn't, I understand the issue you're describing. Like if you have a basin that's drawn down for a long period of time, you can get shrubs growing in there and stuff. And you do want to remove those before you fill it up, so all that stuff doesn't break down and muddy the water. But it doesn't sound like you guys are taking that approach where that would be an issue.
Oh yeah, we will have that all out to the community when we're doing it. Everybody will know when that's happening.
Yeah, I would like to say that I think if you're going to do another study, that's probably necessary. However, I would hope that you would prioritize areas of the lake that did not get dredged several years ago that were supposed to. So please keep that in mind.
Regarding this dredging project, the prior administration under Eric was one I was in communication with quite a bit on the dredging project. And it was a constant chain of flux. There was going to be a coffer dam established. There's going to be earth moving equipment brought in. There were going to be spoils locations in Lewis Lakes and other areas of available ground. Then Eric got talked into hydraulic dredging. And I said, Eric, the bottom of the southern end of the lake is a trash dump. There's everything in that lake from boulders, logs, pieces of lumber, leftover pieces of beaver dam. Hydraulic dredging is a joke. It's not going to work. They proceeded anyway. Before they even started, the contractor who was working up on Eastern Cove quit. Then they brought another contractor in to stabilize Lewis Creek. I don't know what he did, but I've got a document here in front of me from Eric that talks about the failure of the second contractor to do what he promised to do. So in terms of dredging, there's been talk, there's been plans, there's been half-ass efforts, but it never gets done. When the time is right, I suggest you concentrate on the southern half of the lake. In fact, one of the questions that was submitted to you was your selection of locations in the lake to measure water quality. The south end of the lake is a little bit different world than it is in some other locations. It's more shallow, the water's warmer. There's a great deal of silt intrusion from the creation of Lewis Lake Island itself. It's a very, very interesting, diverse area. And the silt content is as deep as it is anywhere in the lake.
Thank you.
I have one other question. Years ago, they used to lower the lake at winter time to help preserve the bulkheads, and help with the lake management at the end. Why did they stop doing that?
You know, Mike and I were driving around today, and I've been here a little over 2 years. I didn't know you even drained the lake down then because, you know, Mike and I, one of the facilities I worked at, we would drain the lake every year. We would bring it down probably, we were about 15 feet. We bring it 10, 15
Yeah, I
feet.
think
We would bring it down.
periodically there'd be big
Yeah.
drawdowns.
I don't know. I would love to know when they did it and
Well, we bought in the 90s and they used to drain the lake at that point. They would bring it down every year. They'd
this
bring it
main
down
lake?
at least the north. Yes.
Okay.
Anybody else remember?
oh, wow.
They would drain it a good 2-4 feet down.
I
Easy.
had no idea that. I mean, you can always drain it down. I mean, there's nothing saying we can't. And I would get with Mike on that and see what would be the positives and negatives for that. I know most of you don't pull your docks out of the lakes, which I find odd, because you could get ice damage and break them. So, but no, I can talk with Mike on that and we can look at the pros and cons of pulling the lake down a little bit.
Yeah, definitely.
Just one question. We talked about funding, available funds. So Joe, help me if I have this right, that the North Lake actually feeds into the Lehigh. Does it?
No, this lake here feeds into the Lehigh. So yeah, Trout Creek comes, well, you start out of Brady's Lake, come down Trout Creek, come into this lake. Our dam here by the MSC building is Trout Creek and it goes into the upper Lehigh.
So would that be a tangent for funding, that the fact that our lake actually runs into other, the river?
It's part of the story that you want to craft as part of like any grant application, that you're the headwaters of the Lehigh and so forth. The hurdle is that you're a private community and a lot of the funds are earmarked only for public access and public property. We've had some success working with those bumpers by getting a sponsor, where they would be the grant recipient on your behalf. It takes time finding that person, developing that relationship and getting those projects identified and so forth. But it's something that we, hope to do long term. But you're right, being the headwaters of the Lehigh is important.
We are so fortunate in this community that have allowed so many renters and Airbnbs to take access to ours. It almost comes to a point where I really don't even think we are a private community anymore. Everybody is available. If you want to make the price and put out Venmo, you can come into our community. Can we make that as a logical or illogical suggestion to being public accessed?
I'm gonna answer this one, not until you take your gates down. Your gates, you're gated.
Yeah, typically, like if you have a public boat launch that's accessible like for free, that would be a little different. But paid access via rental property, I don't think would work.
Do we have any other questions? Michael, thank you.
Thanks.
Great presentation. Thank you. And thank you for everyone who came out. You had some very, very good questions. And again, thank you, Michael. I look forward to keep working with Princeton Hydro.